Let's take a look at some other problems we have with scientific notation. These say to evaluate the expression and write the result in a scientific notation. Basically, we're multiplying 2.5 times 10 to the fourth times 5.8 times 10 to the second. Now what we can do with this, it's basically all multiplication, is we can change the order. I want to multiply my 2.5 times my 5.8. And then I can multiply my 10 to the fourth times my 10 to the second. So if you just go 2.5, again, it's all multiplication, we just change the order, times 5.8, that becomes 14.5. And I'm going to go times 10, because scientific notation, and our answer must be in scientific notation, is always times 10, raised to the, well, same base being multiplied, you add their exponents and get 6. Except this isn't the right answer. Remember, scientific notation is a number between 1 and 10, and 14.5 is not a number between 1 and 10. So all we have to do is move our decimal place over one time to the left. Now for adding another decimal point, we've got to actually add another spot to move it here. So instead of multiplying, if we're moving it over once, instead of multiplying, remember 10 to the 6th is a 1 followed by 6 zeros. So instead of multiplying it by 1,000,000, because we're moving it over one more time, we're going to multiply it by 10 million. That's why we're adding another 0 here. So our solution actually ends up being 1.45, moved it over once, times 10 to the 7th. That's a little trick here you just have to be careful of. If you're adding a decimal place you're going to have to move over, you've got to add right up here to your exponent. Now if you look at this one, it says 1.82 times 10 to the negative 1 divided by 1.4 times 10 to the negative third. I'm going to rewrite this, even though I am using the x, so I hesitate to say write this properly. I don't want to use a division sign. I'm going to use 1.4 times 10 to the negative 3. Now the reason I want to do that is because I'm going to focus on these two separate parts. I'm going to divide this part, and then I'm going to subtract my exponents because I'm dividing with the same base. So if I just grab my calculator and go 1.82 divided by 1.4, I get a solution of 1.3 times 10. If I subtract these, negative 1 minus a negative 3, this becomes 1.3 times 10, because it's always times 10, keep, change, change. Negative 1 plus 3 is 2. So my solution is 1.3 times 10 to the second. Again, ladies and gentlemen, with both of these problems, you just kind of match things up. Here I changed the order because it was all multiplication to make things work. Here I wrote it so I could work with two individual pieces. I could work with the decimal part and I could work with the 10 to whatever power part. Now if you look down here, we have the quantity 1.5 times 10 to the negative fourth raised to the third. Now remember our properties of exponents. If this is in parentheses here, that means that 3 goes to everything inside parentheses. So this becomes 1.5 to the third times 10. Remember, we multiply these exponents. Negative 4 times 3 is a negative 12. Okay, again, this is like to the first, so 1 times 3 is 3, negative 4 times 3 is negative 12. If you go 1.5, raise it to the third, that becomes 3.375. And since our decimal point, this is a number between 1 and 10, we don't really have to do anything else to it, times 10 to the negative 12. Okay, again, remember if you had to move it over one time like we did here, you'd have to add another decimal place to your exponent. Okay? So with problems dealing with different operations, if it's multiplication, all multiplication, you can change the order, keeping in mind your properties of exponents. If it's division, same thing, kind of match it up, keeping in mind your properties of exponents. Well, and even if it's a power raised to a power, use the properties you've used and practiced.